Hi everyone, Chris Kuzmal here. Today we're going to be talking about the definitions concerning continuity, differentiability, and limits. Intuitively, if you just take a pen, put it down on the left-hand side of the page, and draw to the right-hand side of the page, as long as you keep moving to the right and don't double back, then you will have drawn a continuous differentiable function that has a limit at every point. But that intuition isn't all that helpful unless we see some counterexamples for each of the cases. Some functions are undefined at certain points. The square root of x is undefined when x is less than 0, in the event that we're confining ourselves to answers that are real numbers. 1 over x is undefined when x is 0 as well. The log of x is undefined when x is less than 0, and I think it's also undefined at 0. And the tangent of pi over 2 is undefined, and other similar points for the tangent function are undefined. Those are specific examples. It's certainly not an exhaustive list. There's an infinite number of functions that are undefined at a given point. But these are key ones to know about to understand why each one is the way they are. And actually, when they become defined, in particular, the square root function becomes defined for values less than 0 when we change what kind of answer we can get back from the square root to become a complex number. On the other hand, the reciprocal of x remains undefined for x equal to 0 in almost all circumstances I'm aware of. A limit exists when the function approaches the same point from both sides. And here you look at this graph of these two lines, you think, well, there's something wrong with it. It's not a function. It's not. You didn't keep your pen down as you drew all the way from the left to the right. You picked it up and then you put it back down, and you had also changed directions, so to speak. But nevertheless, as you approach from the left and as you approach from the right, these two lines approach the same point if these two lines ends actually are infinitesimally close together but not quite touching. That's a situation where the limit exists, even though the function is not even necessarily defined at the point where, in fact, the limit exists. So the limit can exist where the function is not defined. Okay? If you don't play any tricks at the point itself, in other words, officially we say f of a equals the limit of f of x as x approaches a, which sounds like, well, of course, that's always going to be the case. Well, not always. You can have you can have these two lines back here. You could actually put in a point that was not where these two lines approach. And if it's just that one single infinitesimally wide point, you would make it so that the function exists everywhere. It's defined everywhere. The limit approaches the same value from both directions, and yet at that particular point we have funky business and make it, and so we have to specifically say the function at a has to equal the limit that it is approaching from both directions in order for the function to be continuous at that point. Okay, so that's sort of a definition of continuous. Differentiable is slightly different than continuous. It adds the requirement that the derivative of the function at a given point is the same as the limit of the derivative of the function as it approaches from one side, is the same as the limit of the derivative of the function as it approaches from the other side. If they're all the same, that seems obvious, but if we look at our example here, we've met up at the roof, so to speak. But if we're skiing up, our skis suddenly flop over, our slope suddenly changes. And if our slope suddenly changes, we're not differentiable. Okay, so the limit exists, and this is also a continuous function. And intuitively, continuous function is where we don't ever pick up our pen. And so we can change direction suddenly, our ski, but it's not differentiable. So this is an example of a function that is continuous but not differentiable, a good example to have in mind. There's 16 possibilities amongst continuous, differentiable, defined, and whether the limit exists. How many are really distinct? This is where all four are allowed. You can't get continuous, differentiable, or defined if you don't have existence at a given point. And you can have a pair of points that also meet, which we talked about. They're not continuous, not differentiable, not defined.